Hello student, hope you're doing fine amidst this lockdown. So we are dealing with the circle and its properties. This is form 4 work, maybe form 3 third term work in some schools that have teachers who are very fast. And it is I would like to say one of the simplest topics once you try to understand. So I would request you that understand from the smallest bits that I'm going to start from, which I'm going to start building. And then I would still encourage you that if you have a friend who can afford being on YouTube and having a look at these videos, and then or else contacting me personally so that I can help them, please endeavor to help your friends. Don't be mean, don't be selfish, because we are passing together and we are excelling in life together. So the second is properties. What is a circle? First of all, a circle is simply a set of points that are at a fixed distance from a certain point that we call a center. It is simply a locus of points at a fixed distance from the center. In other words, if I put here a center, I can make a locus of points that are at a fixed distance from the center. So this is going to be my circle. The distance from the center onto the circle is what we call the radius. R is my radius. R is my radius. But then if I call this one A, B, but the distance, if I added the C, the distance BC is what we call, the distance from here to here is what we call the diameter of a circle. The diameter of a circle. We are starting the building. The diameter of a circle is equal to twice radius. Help me remember this. The diameter is simply twice the radius of a circle. So we can try to look at, remember that the circumference of a circle is the total distance around the circle. The circumference is given by the formula twice pi r. But since we know that diameter is equal to twice the radius, 2 times radius, my circumference can also be called pi d. Can also be called pi d. So it is circumference either twice pi r or simply pi d. So maybe a simple example. If you're told to calculate the circumference of a circle whose radius is 7 centimeters. If you're told to calculate the circumference of a circle of radius 7 centimeters, we know that from circumference is equal to 2 pi r. So I have if you take pi as 22 out of 7, I have 2 multiplied by 22 out of 7 multiplied by 7 centimeters, such that this by 7 ones, this is 44 centimeters. But my main issue here is help me remember that circumference is equal to twice pi r or pi d. What about the area of a circle? The area of a circle. Help me remember these facts. They are simple. So if I have a circle of radius r, from the center to here r, the area over the whole circle, remember the other one was simply circumference, but the area of the whole circle, the area is given by the formula pi radius squared, or simply pi r squared. But what do we know? We know that diameter is equal to twice radius, meaning radius is equal to diameter over 2, meaning the area of a circle can assume a new formula. Area will equal to, so where there is r, I put there d out of 2. In other words, the same as pi d squared out of 4, because where there is r squared, I'm putting there d out of 2, so it is d squared out of 4. So we are building. So we have another simple question here to just help us remember. So we know that, so they say calculate the area of a circle with diameter 0.5 meters. We know that area is equal to, so we have here diameter. Let us use the formula that we've just learned. So area is equal to pi d squared out of 4. So I can have it as 22 out of 7 multiplied by diameter squared, which is 0.5 squared. But then I'm multiplying this by a quarter. If you use your calculator, this gives you 0.196 in meters squared, because it is area. So let us now build into a new algorithm. So we are building on into a new algorithm whereby we have the chord, arc, and sector. The chord, arc, and sector. If I draw a circle, and I have a line there moving from here to here, if I call it A, B, if it is not passing through the center, this is what I call a chord. So a line joining any 2 points along the circumference but not passing through the center is called a chord. AB is a chord. AB is a chord. Then if I come on the center, I draw a line, and I draw there another line. Allow me put here an angle that I can call theta. Allow me call this one CD, and then this one is O. If I call this one CD, then this one is O. The point C to D is what we call the arc. C to D is an arc. C to D or CD is an arc. This CD that makes the angle alpha, the distance simply from here to here is like a small one, so we call it the minor arc. This is the minor arc. But then the reverse, CD, this one is the major arc. So on the arcs, we have there the major arc and the minor arc. The minor arc is the small one, and the major arc is the big one. Still on the same thing. So if I come and I shade this region, the shaded region, this one is a segment, but because it is the small region, the shaded region is what I call the minor segment. And then the unshaded region is what I call the major segment. This guy is the major segment. The shaded minor, the unshaded, the whole of the other one is the major segment. This angle I've put here, this is a Greek letter that we call theta. Theta is the angle. Theta is the angle. The minor arc subtends on the circumference is the angle the minor arc makes or subtends on the circumference. Theta is the angle the minor arc subtends on the circumference. Yeah, so I think this is a good introduction into our circle and its properties. The next videos, let us go into the calculations and how we use what we've been talking about. Otherwise, like our video, and then still remember to subscribe to our channel such that we can build you into a bigger and better mathematician.